I'm so happy today to have Linus Larsson Green, the CEO of Pulpac, which a company that has been making waves in the molded fiber industry by completely transforming something. What, Linus? It must have been a 50, 60-year-old technology, the wet molding. And
Sure.
you guys are totally taking it by the horns and shaking it. So I've been really excited about getting to talk to you, Linus, and thank you so much for agreeing to being on the show.
Thank you. Thank you. Happy to be here.
Great. Let's start in the beginning. I know that your dad and you have been involved together in evolving this technology, but talk to me about your growing up years. What were they like, and why was there things already in the growing up that led to what you do today?
Sure. Oh, that's an interesting question. Yeah. Yes, it was, right? To start with, I've been working almost my whole work career together with my father, right? And he is an entrepreneur. And my family was sort of a creative family, I would say. I have a sister who is now an artist. She does paintings. I have a mother who is also into creating stuff. She does ceramic, right, where she does mugs, cups, and that sort of thing. So I grew up in sort of a creative family, and we used to have a complete tool shop or workshop in the basement of our house. So I'm quite used to build stuff and do that kind of thing, right? So it was a fun time. Since then, I mean, yeah, he we founded the company together, right? But he has actually done it before, so he is a serial entrepreneur, and the business model that we have chosen, I think that is a heritage from him as well, right? With licensing and the possibility to scale. We'll get into that as well, I guess. But I mean, he has done something similar previously to what we're doing to Pulpac. He was once in robotics, but also in printing, and now into fiber. So it's a widespread of things. But I think that innovation actually it comes from a broad perspective, and that is what I also had when I grew up, right? So we used to build a lot of things. We were creative at our house. It was a fun time. It was a happy upbringing, right?
And were
Yeah.
there things when you were growing up that impacted you about ecology? Of course, I've spent a lot of time in your beautiful country, so you don't see so much garbage around. But I'm
Yeah.
sure there may have been incidences that reach out to you that you have to do something about this. How did that evolution happen of the ecology?
Sure. That actually came later to me, at least, right? I mean, yeah, I mean, we live in Sweden. It's a nice country, right? From an ecological standpoint, right? We have nature. We used to spend our summers by the coast, swimming in the ocean, that sort of thing. So it was kind of happy and clean all the time, right? I didn't think, I would say, when I was in school, that I would work within sustainability. That was not really a thing back then. I mean, back in 2010, I guess, is the first time we started to realize that we have a problem as consumers, right? We started to have some reporting in Sweden about pollution and plastic waste and that sort of thing. And actually, from my work, I mean, I used to be a consultant as well and working with innovation with other companies, big companies, and they started to ask questions. Okay, something is happening here, something that we can actually dive into and perhaps solve as well. I don't know. When did you hear about the great garbage patch in the Pacific Ocean? Right?
I don't know about the great garbage patch, but thankfully, I don't know if it's thankfully, but I grew up in India, which meant that I
Yeah.
was surrounded by garbage. And my parents, again, were very, very ecologically minded. So my
Mhm.
wife, my wife later, but my father couldn't even cross if there was a tap just left on. He had to shut every
Wow.
tap if he was walking, or pick up every bit of garbage, which is really difficult. So for me, it was easier because I was just so surrounded by garbage that it was like, I have to do something about it. But yeah, the great garbage patch, heard about it maybe 10 years back ish, 5 to 10 years, somewhere there. Yeah.
Yeah, yeah. It seems similar to what we hear in Sweden as well, right? And I think also in Sweden, that is when we're starting to see, you know, garbage piling up by the sidewalks and streets and stuff like that. Plastic waste, sort of. Before then, I mean, it was pretty clean. Interesting,
And
yeah.
and what part of Sweden did you grow up in?
So on the west coast in Gothenburg, yeah.
Ah,
So
you won't,
born
you
and
won't,
raised, still
you,
still live here and work here, yeah.
yeah, you won't believe this, but I've spent a lot of time in Sweden, all sorts of places, Aarhus
Ah,
and Osby, and north of Stockholm, and every corner you can think of. But 2 months of our uh, life, my wife and I decided to live in a little island called Brno off Gothenburg.
okay, Brännö, yes, of
Brno.
course.
I know I
Yeah,
was
yeah,
saying
yeah.
it wrong.
Fantastic.
So we lived for 2 months in Brno, and it was beautiful. And just that island life, we would, because there were no vehicles on that island, and we were a great community. We know a lot of people there. So we just kind of, there was a friend of mine who was an Iyengar yogi, and I would practice with her every day, and then we would get out and do things. It was a very interesting time, but a beautiful place. That whole archipelago, and another friend had a beautiful yacht, so we would take that out and go to the different islands. So I'm sure you've done a lot of that.
Sure, yeah. Sailing is a big hobby here in Sweden, I would say that. When was this?
2019, just before,
2009.
yeah, 2020 was COVID, so August, September of 2019.
Yeah. So how did you perceive the beaches?
How did I perceive the breaches? So there
Were they
was,
clean or?
because this was mostly rocky land,
Yeah.
so it wasn't that many beaches there. Um, but it was beautiful. It was clean. There wasn't that much trash, and yeah, I did. I don't think I would have been as influenced as I am now if I had grown up there. Similar to what you were saying,
Yeah.
it was not while growing up that you could see the kind of muck that we have created.
Yeah. We have quite many incentives as well, or initiatives, right? Where people actually go out and clean the beaches and do that
Uh-huh.
sort of things as well. People are quite engaged these days, yeah.
No, and Sweden has always been a very conscious country, and like people in general are of a higher awareness of what is happening. So I think that helps as well. I want to stay with your dad, actually. You
Yeah, sure.
mentioned about his entrepreneurial instinct and his innovation, and the statement you made is really beautiful. You said innovation comes from different sources, and this, widening your horizons. So, talk to me about the learnings that came from a father who was always trying to do different things. What were the things that he did, and what were the things that really excited you while you were growing up from seeing what he was doing?
Sure. Yeah, so mechanical processes from a general perspective is quite close to my heart, and that must come from something, I guess, right? To see machines tick and move and do stuff, right? I think that is very engaging and inspirational. Growing up, I think he actually did a lot of different things. He was quite early on to also computer animation. So he actually made a kid show here in Sweden once as well. So yes,
That's crazy.
it's a wide variety of different things he did, right? And that is very inspirational, I must say. Of course, yeah, and to be creative with the, I would say, sort of simpler materials and that sort of thing is also quite important, I would say. I mean, we used to do a lot of crafting and that sort of thing back home. Paper, I mean, we have talked about this ever since, right? But I mean, we used to do a lot of things with paper as well, and I think that is a fantastic material. Build stuff, models or houses or play stuff or whatever it could be, and that is very inspirational. But the variety, I think, is a key thing here, right? Many different things and technology from an overall standpoint.
Yeah, super fascinating. And you ended up going to Chalmers University of Technology, I think. And tell me more about your education and what you did. And then you mentioned briefly that you consulted for some time before
Yeah,
starting Pulpac. So
yeah.
tell us about that journey.
Yeah, sure. So yeah, mathematics, technology has always been quite close to my heart. I started studying at Chalmers then, become a mechanical engineer. So I studied for 3 years, I think. Uh, I was supposed to study for 5, so I'm actually a dropout of university, right?
All famous
Probably.
people, Linus.
Yeah, yeah, perhaps I don't know, but uh, yeah, it was more fun to actually be able to create stuff and do stuff, right? So I actually joined my father at his consultancy agency, which we had with some friends of his, and they worked within innovation and branding and that sort of thing. So I would say that perhaps not that part pulled me away from school, but it was more fun. Let's put it like that. I continued to study for a while as well, but yeah, it was a switch, sort of a graduate switch from school to work, more or less, doing the stuff that interested me.
And how did the idea emerge? I want to go into more detail of this because this is like the crux of the conversation. So it'll be great to hear about how this whole idea of first molding emerged and then creating this technology of dry molding instead of what was available as wet molding. How did that whole transition happen?
Yeah. So yeah, I worked for this company for quite many years actually. We did a lot of different things there as well. I mean, we did everything from rescue equipment for windmills. We created new innovations for our clients, and with that, we also created patents and IP, right? But it was like a wide variety there as well. Everything from paint shops for automotive to, as I said, windmills, but also a lot of packaging projects in innovation in that space as well. Tools, hand tools, yeah, you name it. It was the red thread here, right, is that innovation is actually what enables a brand to grow. Not only the branding itself, but it also comes out in what type of products you produce and how do they look and feel and how are they perceived by the customers, right? And innovation is quite a powerful tool. So that is what we did for a couple of years. Did a lot of packaging projects, designs and innovation in that space with various different of technologies. We even did some plastic stuff actually back then. But the question started to emerge more and more, right? Can't we do something else? Can't we do something more sustainable? How can we innovate in this space? And we had a very, I would say, interesting brief from one of the clients, which was more or less, can't we have a funnel in one end of the machine where we just put in a sustainable material and then we can do some digital manufacturing of the packaging to the products in line in our factories. That paired, I would say, with the question on pulp and paper, can't we use it for more? It is a good material, right? It is something that we have in abundance and something that we have infrastructure for. So that led us to start investigate, I would say, known technologies for producing these kinds of items, molded fiber items primarily. Wet molding, as you mentioned, right? I mean, it's an old technology. It's been around for ages, and it hasn't developed. It's starting to develop a little bit, but it has its drawbacks and its physical limits on what it can achieve. But that, I mean, led us to start thinking about this. Can't we do something else? Why isn't it used for more? Why isn't it wet molded? Why isn't wet molding used for more, right? Why do we have plastic cup lids or containers or salad bowls or cutlery or hangers or you name it, right? Even the chocolate boxes comes with plastics inside, even if it's a cardboard box outside. Doesn't make any sense. But when you start to investigate, you quickly realize that it's too expensive. That's what it comes down to. People are not willing to do the switch because it costs more. Even though, I mean, fiber is a very inexpensive material, it's even cheaper than plastics. So it doesn't make sense. Is this something we can do here, perhaps, to enhance the utilization of fiber from a broader perspective? And the easy answer is actually to remove the water out of the equation. And you get a lot of different benefits from doing that. Cost and sustainability features and whatnot. Yeah.
Yeah, but you could have done this project. You were a consulting company. You could have done this project for a client. How did the transition for, okay, we are going to do this? How did that happen?
Yeah. So yeah. So normally you say that the lightning strikes, right? But it was more putting down the puzzle in our case, right? You were starting to investigate and seeing different things, and something that was very common during that phase. I think this is back in 2014, 2015, and the big pulp mills actually starting to see that, okay, plastic perhaps is bad. Perhaps we can actually increase the margin on our products because the demand is increasing, and hopefully we can even do a slot-in solution for existing manufacturing methods. So they started to mix plastics with fiber quite a lot, and raise the prices for those kinds of items. Of course, a blend of material isn't really that good from a sustainability point of view because you can't really take care of it, even if you actually blend it with a polymer that is degradable or whatever, right? But the price is still high and you can't really take care of it in the afterlife and so on. So we started to look into those kinds of things back then, and actually thought that that might be the solution. But we started to do different things, starting to try out, how can we shape these kinds of material. And then I would say when the lightning strikes, right, is when, why don't we remove the plastics out of the equation in total, right? I mean, we get evenly good products without plastics. Heat and pressure from a non-woven. That's all the issue. What was pretty cool then as well is that we started to investigate if this was something that had been done before. We didn't see anyone who had done it the same way we did, and we actually filed for a patent in 2016 and realized that this is sort of a white space actually in terms of IP as well. Later we realized that there were actually a few initiatives, unsuccessful ones, in Sweden, perhaps a little bit ahead of their time as well, who had started to investigate if this could be done because, yeah, there are financial or economical benefits of doing it in this way. But from an IP perspective, it was completely blank. So, yeah, utilizing it more, learning more, right? Gaining client interest as well. We had a lot of clients and we pitched it to them. Is this something you're interested in if we continue to develop? And interest was huge. So 2017, we decided to form a company and started in January in 2018. That's really the background story.
But
How we started.
did the consulting continue, or has it now taken a backseat and every energy for you and your father and the team went into Pulpac? Because that's a big shift, Linus.
Yeah.
You're doing so many different ideas for so many different people, and then this one idea, as you say, lightning strikes, and then you are kind of honing your energy into this one thing. So
Yeah.
how has life transitioned from there? Are you still doing consulting for others, or there's absolutely no time for that? And
No, no, not
how
at
did
all.
how did it transition into like, okay, this is what we are going to do full time, and we are going to put in all of our innovation energy into this one field?
Sure, sure. Yeah, to be a consultant, it is hard work as well, right? You're always yeah, the pressure is on all the time. You can't really relax, right? So instead of just building something linear, it's more fun to build something exponential, and that was really the key, I would say, to make the decision to form a company with a completely different business model as well, to make some impact, to do a change right within the industry. You can't really do that as a consultant. That's not really thrilling enough. So I think that is the main reason we decided to switch. Yeah, we have something here that can actually make a difference, but we need to do it in a different way if we will be successful. So the idea behind Pulpac is really to share, I would say. I mean, we are really trying to set off an avalanche within our industry, which is the converting industry of these 3D molded goods, right? Packaging and products, and to support everyone who would like to get involved, everyone who would like to, or anyone who would like to start building machines, supply materials, or convert products. And that is exciting, and it gives you energy all every day, right, when you go to work. That's yeah, the effects of what you're doing is so much greater than just one project for a single client.
It's interesting that you say that because it's a difficult transition. I've got a few friends who were, say, in education. They were really, really high quality teachers, but there's this one particular friend that comes to my mind. And somebody kind of challenged him. It's like, you teach us all the time that, this is how pulp and paper should be done. But why don't you do it yourself? And he was also one of those people who used to challenge status quo, right? Why do it like this? Why not this? So he actually thought about it and he eventually left academia and went
Yeah,
into actual, and he's the CEO of one of the big companies now. But he actually managed to transition. And it's a similar thing with consulting, right? It's just such a different domain that kind of being able to transition. One is the idea, and also, I think when I'm thinking from an outside perspective as a consultant, the whole mindset is very different because you're talking about so many different things and giving ideas, and your job is done once the basic concept, idea, design, whatever is there is it's basically you hand over and it's done.
yeah,
Here, you're not able to. It's the responsibility is yours, and that includes, I'm sure what we'll get into later. It could be raising finances. It could be, finding partners, etc. So mentally or in a mindset, how was it to transition? More than you, even for your dad, because probably he had spent even much, much longer in the consulting kind of side of businesses and different ideas. So I know you can't speak totally for your dad, but of course for you, and maybe some perspective on how it was for your dad to kind of transition into going deep instead of going wide.
yeah, yeah, sure. I think what you are seeking when you become a consultant is freedom in some way, right? Yeah, these shallow things. You dive into something and do something, and then you move on to the next thing, and you can continue. I think my dad, right? I think he really enjoys the entrepreneurial path, where you get to build something, right? To see it through, and I do as well. I mean, this is fantastic to be able. It's a luxury to be able to do what I do today, right? To build a company, to have all these amazing colleagues and everything, and meet clients and partners, and it is so much more rewarding, I would say, from a personal standpoint, to be able to do what I do today. Not only pitching. Yeah. So yeah, it's an interesting perspective. I actually never thought about it in that way. It was very natural to actually take the step.
So there was no kicking and screaming that,
No, not
no,
at
no, no,
all.
I'm
No, not
back.
at
I'm
all.
going to go back to consulting. This is not good.
Not at all. Not at all. I think we were waiting for something like this, perhaps. Yeah,
Nice. That's good to hear.
yeah,
So when I look at it from a very base perspective, and this I'm getting into the fiber side now,
yeah,
the fundamental idea as paper makers or anything to do with natural fibers is hydrolysis. Ultimately, all the bonding is taking place because of water. That's what attracts fibers together, creates a charge balance, and you play with it. You play with cationicity or anionicity, and bring things together. You've challenged all of that. You've said that, okay, that part is done. I'm going to take dry pulp and I'm going to then bring it together. And and of course, your products are wonderfully bonded. In fact, better
yeah.
bonded, I would say, in many ways. So, talk to me a little more on the chemistry side. How did that evolution happen? That I'm going to take a pulp that has been dried and probably use certain kind of binders and bring it together. So, how did
Yeah.
that whole transition happen? And did you have to bring in people who understood fiber more, or they would be a hindrance because they thought it could only be done a certain way? So how did that emerge?
Yeah, a little bit of both, I guess, right? I think not a lucky shot in the beginning, right? But I think it is later that we realize that we need to have quite good control of moisture levels and that sort of thing. And I mean, that comes from learning, right? I mean, I'm not a chemist. I'm a mechanical engineer, sort of, right? So I don't have the full understanding of how it works. I mean, yeah, what you mentioned is correct, right? You need to have a little bit of moisture to actually make those hydrogen bonds in between the fibers to make it stiff. And you need to control moisture levels. But that is later, I would say, that we are realizing the limits on how it actually are working, right? You could use a bonding agent as well to make it stiffer, or we actually use it in some cases to get some barrier properties out of the material. But it works without. I mean, you can make a pure pulp product and it still becomes very smooth, stiff, and rigid, right? But it doesn't have the chemical properties that you might need from an item that you're using within food service or whatever it could be, right? But in the beginning, it was a lot of testing, right? Empirical testing on how this works. Then we took in, chemists who supported us. Okay, how can we actually enhance it, make it better, and so on. So it was a process, I would say, for the first couple of years to really understand the chemistry behind dry molded fiber and how it's performed best. But what we kept in mind, I would say, all the time is that, yeah, one good thing I would say that comes from the consulting business as well is that we always had the clients alongside with us. And we were always seeking for their approval or their judgment or feedback on what we did. So that has been very beneficial. Is this good? Is this bad? Are you interested if we do this instead? And along with that comes also the financial incentives for them to do the switch. So we can't do something completely crazy if it costs too much. We need to still be viable from an economical standpoint. And that, I think that was very beneficial for us, especially in the early years, because that steered our R&D and our innovation. Yeah.
So, relatively straight question. Why is it better than wet molding?
Yeah, it's quick. It's very quick. You can produce a lot of products very fast. If you compare the return on investment on the equipment, it gives you a completely different price point on the products. I mean, our goal is to replace single-use plastics, right? And that means that we need to be price competitive with plastics. And in some applications, it's tough because it's so well developed for so many years. The speeds of those machines are incredible, and plastic is relatively cheap. But on some products, we are on par or competitive even. But I wouldn't say that our in different parts of the world, right? It varies. So in some parts of the world, we are competing with plastics. In other parts, we are competing with wet molding. So it varies. But yeah, that's the simple answer. It's fast, and it's quick, and it makes cheap products.
What about the product quality itself? Is there a difference? Because when I see your product, I definitely find it stiffer and smoother. So if you look at the product quality, how does it differ with a good wet molded product?
Yeah. Yeah, smoothness, rigidity. I think many of those attributes could tell you what a dry molded product is. But we also have better control of the product specification. I would say the thickness, the grammage of how heavy it is, surface textures. We can engineer that. I mean, the process itself reminds you of thermoforming in plastics, where you have very good mold replicability, right? Where you actually you can see surface textures, you can see embossing, debossings, that sort of things, right? Cutting edges. We have, all in all, better control of the product, I would say, compared to wet molded item. So not only that it is cheaper, it is also a better product from many perspectives. And it comes with great sustainability features compared to wet molding. We don't use water, we don't use heat to dry out the products, right? And in many cases, you actually use gas to heat the ovens for drying these kinds of wet molded items. It's not good. The LCA of a wet mold compared to ours, I mean, we are roughly 80% lower in CO2 emissions than wet molding. So, yeah, we have all those kinds of benefits attached to a dry molded item.
Super. Let's stay with the process. So of course, I think many of the listeners might have a little inkling of what you do, but most I think won't, because this is a drastically different thought process and technology. So it'll be great for you to be able to explain how the holistically the technology works in terms of converting a dried pulp to a molded fiber product.
Sure. So we use a raw material that is essentially pulp in its purest form. We normally use a high grade pulp, which is called fluff pulp, which is being used for the hygiene industry, where you make diapers and that sort of thing, right? It's an engineered pulp that is very easy to redistribute via a mill, and that is what we do as well. We utilize somewhat scaled down non-woven air laid technology, right, to actually make a very fluffy ductile web, almost like cotton in texture. And that web, that material, is much more easy to shape into a 3D model item. We could use other types of pulps as well, but fluff, I would say, is the primary goal now. It's available, and all the big pulp mills are producing it and selling it, so you can buy it almost everywhere, right? Then we take this web and we can actually modify it as well. So what we do is that we can spray on a barrier. We can use the commonly known like binders or hydrophobic agents and that sort of thing. And we spray that onto this fluffy web. Then we coat it with a tissue as well to protect that sprayed on barrier. So we do everything in line. We convert the material from its rawest form into something that actually is suitable for the end product and gets the properties that we need. Now we have the complete material, right? We have sort of milled it into a ductile web. We have modified it with some chemistries, and then we're feeding it into a press, a hot press, where we are having our tools, right? And in here, we do everything in one step. So we are forming, bonding the fibers, cutting it, shaping it, building all the features that we need. And we are applying high heat and pressure very quickly to the material. And this is what makes it efficient. One step process, everything in once. Then it comes down to all the automation around it, right? So the speed of the machine is actually limited by how fast we can move material, how fast we can eject products, or apply pressure and transfer heat into the material and so on. And that's physics, right? It can be done very quickly. And that's the beauty of it. The dwell time when we are actually pressing the products are a fraction of a second. Then you get scrap around the product, right? Because you are sort of stancing out the products out of this web. And that we are just remilling, regrinding into to loose fibers again and feed back into the beginning of the process. So, I mean, the utilization of material is not 100% because we get some dust and that sort of thing that goes through the filters and so on, but 99%, something like that, which is very good. So that is basically how it works. High efficiency, good control of the material properties, thickness, chemistry is applied, the product you shape as well. Yeah.
Thank you for putting it so succinctly, and it sounds so simple, but I know it's not. But tell me, let's start with the fiber. So when you look at the fiber, of course,
Sure.
celluloses can come in many ways, and
Yeah.
of course, Sweden has a very rich northern pine kind of fluff pulp that you can get. But there are many other fibers around the world.
Yeah.
How do you see that? Do you think that it is fiber agnostic, or do you think that it is going to be different in different fibers? How much have you experimented with different fibers? And I especially want to also refer to agri waste, which is a lot of fibers that is being used in wet molding, for example. So yeah, tell me about the input material and how much difference does it make to the output depending on the fiber?
Sure. Yeah, yeah. It plays a significant role, right? Of course, it does. The fiber length, especially, I mean, that is what determines the rigidity of the end product, on how much bonding we can actually get, and the stiffness of the products. We have done a lot of testing and will continue to do so, because if we can lower the input material cost as well, I mean, that would make a huge impact on the business case and unit economics, right? Meaning that we can replace even more products, become even cheaper than plastic in some cases. So it is of high importance. We have clients that are doing blends with agri waste as well, which is very interesting. Scrap, so they have their own processes where they actually mixing it in and do blends. So something that we are continuously investigate as well, and other formats of pulp as well. I mean, we use a reel format in order for us to feed continuously into the process. But I mean, to be able to run bales or other formats, it all comes down to availability as well. We need to have the amount of fiber we need in order for us to convert as much as possible. And agri waste, recycled fibers, that sort of thing, very interesting.
Most of the products that I've seen from Pulpac are bleached and I think mostly using wood or softwood fiber. What would happen, and this may be a hypothetical question, or maybe you've already tried it. What would happen if you were to use an unbleached bagasse fiber and
Yeah.
you could get it in a fluff form? Even theoretically, what would happen? Would it work the same or would it be different?
It would work the same. It would work the same for sure. The rigidity of the product, I can't tell you anything about that with the pure bagasse format, but we do a lot of things in unbleached as well, actually. And the lignin that remains in the unbleached actually gives us some properties when it comes to certain applications. If you mix that with binders and some other additives, yeah, you can get good properties. So it actually helps in certain cases. I mean, we are really trying to make sustainable products, and we talk about chemistries and different types of additives as well. For us, it's important to stay within regulations, and there's a lot of talk of PFAS, for instance, which is a terrible sizing agent for paper making. You have that in all types of products, like everything from cup lids to bags for dog food or whatever it could be, right? I mean, that is not part of the future, right? So we are trying to find these new innovative types of chemistries that are natural, that will degrade or be able to be recycled within current waste streams. And to utilize what's already in there is very exciting, right? To have materials that actually gives you, yeah, better qualities in the end products. Like if you utilize a little bit more lignin, which is already in the wood, that's fantastic from my point of view.
Super interesting for me that you mentioned that because it's like inversing the thinking, right? When cellulose grows as a plant, lignin is used as the bonding agent. And when we make paper, we are trying to remove the lignin so that it can hydrolyze better. And that's the constant effort. And it's super interesting to hear that actually it's not that bad, especially if it's dry molding, that okay, if lignin is there, it's there. It's not, you're even saying that it may be beneficial, not just be neutral. So that's very interesting for me to hear.
Yeah, and a mix between fibers. I mean, things start to happen. I mean, long, short fibers. You start to do blends and that sort of thing. Yeah, it's very cool. Yeah,
That's also very interesting for me to hear from a perspective of a person like me who has been very inspired by nature. Many times, and I'm sure you may be aware of this, but many times in nature, it's not the blending of different materials, but it's the physiology. It's how it may be longer fiber in the bottom and shorter, and nanocellulose is on the top, and that's what creates the hydrophobicity, for example. So I think as you go along, it'll be interesting to, if you're not already doing it, to be able to experiment with different lengths at different levels of the product as well, and that might create a different magic as well.
Sure, absolutely. Yeah, yeah. I mean, that is what we do, right? We're trying to develop new types of product and enhance fiber for its application, right? Some things we can't do today. I mean, oxygen barriers are very hard to do in a sustainable way. You need to have plastic films. That is too bad. Perhaps in the future, I mean, this is the exciting part. Perhaps we can do that with a fully natural material.
That'll be amazing because obviously nature does that all the time. It's just that, when we do it in industrial forms, it's very different. But nature also grows its packaging with the product and lets its packaging die when the product dies, including our bodies, right? Our packaging dies as well when we die. So that's the difference also in we have to continue to have the packaging perform while the thing inside is still kind of has to be kept in a certain shape.
Yeah.
So that's
The
the
banana
interesting
peel.
bit.
The
Amazing.
banana peel.
Yeah. It even gives you its expiry date.
Yeah,
You
yeah,
can tell from
exactly.
the outside. You
Yeah,
don't need an expiry date on it. You'll be able to tell many fruits, not just banana, but banana is of course an amazing packaging. Okay,
yeah.
staying with your couple of things, let's stay with productivity. And that's
Hmm?
super fascinating, again, what you mentioned. And that was the first thing that you said as soon as I said, what's the difference? Uh,
Yeah.
so when I look at the wet molded process, and I'm going to shift to tons instead of number of plates, and that may not be the right measure, and you can correct me on that. But if I look at tons, the best performing machines that I find today are little over a ton on an average product. Say they're making a simple, 9-inch bowl or something or a plate. It'll be about a ton and a half. So that's the kind of output I can get from that, and that can convert to a number of plates, etc., etc. So when you look at a much higher productivity, you're talking about 10 times because 30 seconds versus 3 seconds is a totally different ball game altogether. So if you today, in terms of the designs that you have, if you were to choose the fastest and the biggest model that you can create, what would that tonnage transform to on a daily basis?
On a daily basis. That's a very good question. The largest production machine we have today can produce roughly 180 million lids, drink lids per year. And to translate that into tons, I mean, what we do is that a lid, it weighs roughly 3.54 grams a piece, something like that. And I mean, yeah, of course, it's good to be able to convert as much material as possible, right? And I think the large machines can convert roughly 400 tons, something like that. But I mean, if you can actually lower the product weight as well and produce more product with similar properties, that's even better because that will also actually add incentives to the manufacturer to switch. And that is a drawback with wet molding. You need the thickness and the fiber you must lay down in order for you to get the solid coating of the tool, right? It's very narrow if you compare to what we do. I mean, we can do very thin stuff. We can go down to, we talk about GSM, grams per square meter, in paper making in general. And I mean, we make lids that are 300 grams per square meter and still have a rigidity to it. So it works like a product should for a cold drink or something like that. But we can also make, I mean, single-use cutlery with 1200 GSM, a very thick, sturdy part which actually holds for the purpose, or hangers which are almost 2000 GSM, very thick, comes out a couple of millimeters thick, sturdy enough to hang a heavy coat on. So it's all about actually designing the product for function and the number of products, and it should be very smooth and designed for purpose, I would say. That would be the end goal. But in terms of quantity, yeah, a little bit more then, I guess. If you run a wet molding for a ton a day.
But I guess the number of products, what you're basically saying is that the tonnage may not be that different, but the numbers may be very different because of the rigidity and the thickness or thinness of the product. And I see that in your products that it's very, very rigid and it's much lighter than a wet molded product. So I see what you're saying, and you actually ended up taking the most difficult product. I was thinking, let's stay simple, a 9-inch simple plate, but you actually took a cup lid, which is actually in a wet molding system, it'll probably be the worst tonnage that you can get. So I was intrigued when you actually took that product rather than a simpler. I know that you can create bowls and plates, etc., as well from your
Sure,
machines.
sure, sure. But it's all about price competitiveness, right?
True.
That is what it's all about. And the wet molded ones are expensive due to the fact that it's inefficient. It is a slow process. But we're starting to see companies invest more and more in this, which is interesting, right? I mean, plastics is out, fiber is in, and wet molding is the current, I would say, largest scale molded fiber solution out there. And we are here to challenge that with dry molding.
And when you look at, you talked about a little bit, you inferred to the shapes and sizes, and I'll translate that to tooling. So,
Yeah,
so when you look at the tooling, so typically in a wet molded process, what I see is that people want flexibility, and they
yeah,
talk about different designs being made on the same machine by changing the tool. And there's a lot of R&D that goes into, how quickly can you change the mold or the tool. Is that something that you guys play with as well, or it's a different business model where you don't change the tool so much? How does that work?
sure, absolutely. You can change the tools in our machines as well, and you can produce a number of different things. Uh, but I mean, for us, it's so wet molding is very suitable for smaller volumes, I would say, in general, or perhaps even more complex parts, which needs uh, very deep draw with ridges and that sort of thing. Like when you I don't know if you have bought a new TV sometime, and we used to get styrofoam on the edges, right? Now we get wet molded items. I mean, yeah, the cost for those kinds of parts is fairly high, I would say. What we are after is the big volumes here, the commodity items, and that is where we can make the change. So um, many of our clients, I mean, they buy a machine to produce one item, of course, with their design or whatever it could be, but it is high volume. I would say that is the big change here. The, yeah, the next level thinking compared to wet molding, and that's the way you think within plastic converting as well. You need to produce high volume in order for you to be successful.
And I couldn't agree with you more. If you have to make change at a scale, you need to be able to produce the same product at a higher volume. I remember when I was much younger, this is 20, 25 years back, and I used to be really motivated by a lot of the Scandinavian mills because the
Yeah,
consumption, and if you look at a Finnish mill, Sweden still has more consumption, but if you look at a Finnish mill like a UPM or something like that, and I remember there was, I can even remember the name, and this is surprising after 25 years, it was the Tervasari mill that would make 200,000 tons, Linus, of just release base. And only
yeah,
5% was consumed in Finland. But they were so good that they were able to sell their paper across the world because it was the best release base you could get. And the costs were lower because they could do it at a certain scale. And they were not changing it every day. And I kept telling our teams that, why do we have to keep changing GSMs and products on the same machine? It's so inefficient to do that. A little switch also makes a difference. Why don't you just run one GSM, one product, and try and sell it? But I've seen the Scandinavians being able to do that and be able to spread their kind of products wider. And it's interesting that you mention a similar thinking when it comes
yeah.
to products as well.
It is similar, but it differs from client to client as well, and that's interesting, right? Because yeah, we have pulp mills as clients, right? And they are used to big machinery, as you were saying, right? I mean, they just want to run large volumes to get out there. But I mean, what we're trying to do as well is really to talk to the plastic converter guys, and they are used to something completely different. I mean, they are used to injection molding or thermoforming, which is smaller machinery compared to a paper mill, like the UPMs, right? I mean, it's a huge investment for a paper mill. I don't know how many hundreds of millions you need to invest to actually get a paper mill, right? But it's huge. And it's a little bit different thinking here. I mean, when you do plastic converting, you actually buy a machine for a purpose. It's a smaller machine as well. And we need to talk to those guys as well. And therefore, we have now a variety of different solutions. Yeah, we have the bigger machines, the modular ones, but we also have the smaller ones. And we just released one last year called the Scala, which is actually based on an injection molding machine, an entry point machine, or something that is actually mimicking the infrastructure of injection molding. So it's actually both. But normally I would say you want to buy a machine, plug it in, press play, and produce items. It's a very cynical word, but it's yeah. You buy ATMs more or less. That is what you do.
It's definitely good for the customer, like if you can
Yeah.
just buy, plug it in, and, start. Because, of course, like as soon as you go for the wet process, there is a lot of pipelines, there's a lot of vacuum, there's a lot of heat. As you mentioned, in our
Key.
machines that we produce, we use thermic fluids. So, instead of electricity, so then there's a thermic fluid boiler, and that has to bring in the heat. So and you mentioned this before, and it's a very, very interesting, and it's very important to highlight this aspect of the carbon footprint and the LCA. And you said no water consumption, obviously assuming that the pulp would have taken whatever water it has to produce, but your input hasn't got any water and there's no water recycling needed. But you
No, we
did
don't have any
mention that you
process
need
water.
heat in
Yeah.
order to bind. And I presume that would be much lesser than a wet molding machine because you're not drying anything from, down from whatever 15, 16% of dryness to 90% of dryness. So what is the difference in terms of water? I guess there is no comparison because you're taking a dry pulp, you're keeping it dry. Heat, what is the biggest? Yeah, I'm sure there's a huge difference. And what would that be like when we are actually using heat for your process versus a traditional wet molding process?
Yeah, sure. I mean, the energy mostly goes to removing the water, right? When you do wet molding, you have like what is it, 1% fiber in 99% water. I mean, in our case, we are controlling the moisture. We don't have any processed water. I mean, we are controlling the moisture by actually applying in some cases. I mean, in Sweden in winters it can get very dry, so then we actually need to have a little bit of humidity that enables the fibers to bond, right? So to control that is important. The heat we have is basically what we apply in the tooling. So the chemical process to actually get those hydrogen bonds to be created, that is what we utilize. Some sizing agents that we use also needs a dwell time and some heat in order for them to actually emerge. And we use something like synthetic waxes and sort of things to make products hydrophobic, and those needs heat as well. So that could be a post process in some cases. But compared to wet molding, where you need to have long heating tunnels, where soaking wet products with 40% fiber, 60% water, you need to actually evaporate all that water. It needs a lot of energy. So in our case, yeah, top of my mind, a tenth or something like that in energy consumption. It's completely different, completely different.
Well, I remember another company, and you may or may not have heard of it, but or may have because they were based in Sweden as well. It
Mhm.
was called Cellwise, and they were
Yeah.
trying to kind of again very, very innovative. I have not heard from them for 2 years or something now, so I don't know if they still exist. But very interesting that they were trying to create the wet molding process, but much higher heat and pressure and
Mhm.
much more accurate tooling. So they were not inversing the whole thinking process, but they were challenging the process that the regular wet molding was utilizing. So is there probably they took inspiration from this idea of a higher pressure and heat as well. So do they still exist? Are they still kind of
Um,
working? Do you know?
I don't know actually, but it was a long time I heard from them as well. But
Yeah.
yeah, perhaps it was 2 years ago, something like that. I
Yeah,
hope they
something
are
like that.
still.
That's when we
I
had
hope they're still
conversation.
operational and doing what they did. But yeah, I mean, to challenge that, how do you get rid of the water? But it's still a physical limit, right? You need to
True.
get rid of the
Yeah.
water after you have actually molded it.
And it's
But
very
it's
difficult to recover. Like in a paper machine, you have these systems of hood and trying to recover the steam and then making it not the most efficient, but making it into condensate and utilizing it again. But in wet molding, it becomes very difficult. I've seen some players like Keyfill trying to set up, vacuum systems to remove the yes, but in the end, you're still losing the enthalpy, losing the heat
Yeah.
in the process, and you'll have to put it through a heat exchanger and bring the water back. Yes, you can recover some of the water, but the heat is gone.
Yeah.
So that's a loss. Whereas in your case, that wouldn't be the case, right?
Yeah. Did you used to work at the paper mill as well, you said?
Me? Yes, I'm born into paper.
Yeah, you're born into
My
paper.
my
Fantastic.
father started a pulp and paper company when I was 6. So I literally my training, my early days, of course, I was just trying to earn pocket money, was to clean the drains and to unload the trucks and to run the machines. So I'm talking 1993. So what is it? 30 years back. So I used to do that and literally grew up with a bagasse-based paper
Okay.
company, and that's what we, in my work, that's what we transformed into a compostable packaging company eventually. But
Yeah. Okay.
and that's my real work. So of course, this is more my passion to meet people like you and learn and see how we can kind of integrate. And also the idea is that how do you spread the word and make more people interested in compostable packaging. So that's the basic
Sure.
idea. But yeah, but it's in my blood. My
Yeah.
one of my the biggest influence I had was this German Lithuanian guy who was 85 when I met him and I was 25. And he would always say, be like the fiber,
Yeah.
think like the fiber. And that's what really
Okay.
got me thinking. And once you think like the fiber, he said everything else is common sense. So,
Very
so
good.
it's very interesting. Yeah,
Yeah.
so long time.
To try 100% bagasse in our process, that is on the list for sure. For
Let's
sure.
do it. We are
Yeah.
your partners for that, and I will we'll
Very cool.
talk more
Yeah.
offline. Okay, so two machines is what I see, modular, and you just mentioned Scala.
Yeah.
What are the differences when it comes to that? You mentioned in passing that Scala is smaller, but would you love to hear the differences in technology and why the two technologies?
Sure, sure. So, I mean, we are actually platform agnostic in general, right? And we have a little bit of a different business model at Pulpac. We don't convert any products, we don't produce any machinery, or don't sell any material as well. So, we are reliant on the partnership network. Um, we are trying to create this avalanche where we actually educate people on how to utilize dry molding in general. That means that we will have many players who are actually building machinery or provides material or whatever it could be, right? And the modular platform is, as it says, it's a modular platform. And we actually have now two suppliers, turnkey suppliers for the modular platform. And those machines looks a little bit different, even though they are the same. And then we have the Scala, which is the first generation of Scala, which is a smaller machine based on an injection molding machine. But the modular machine, yeah, it's a bigger machine. It's modular. You could actually adapt it to fit your purpose. You can do various stuff with it. You can actually realign it a little bit if you like as well to fit other features in the machine much more easily. The Scala is a completely integrated machine. You buy it for a purpose, right? You can do a variety of products, but still it's an integrated machine. It is a plug and play machine. You ship it in a 40-foot container, more accessible, so to say. So those are, I would say, the standardized platform. But we also have clients who have built their own equipment. I mean, very bespoke machinery, bigger machinery, or even smaller in some cases as well, where they take on the learnings from dry molding. And yeah, but I mean, this seemed intuitive enough. Let's do something out of this and build it ourselves. So it's actually there are many options here, and we are here to help, and we can actually direct clients to a certain vendor of machinery. But as long as we get going with dry molder, we are fine.
That's definitely an interesting model, and from a customer standpoint, I get worried sometimes because what you need from a customer standpoint is somebody to take all the guarantees in the end. Because say what is ultimately happening. Say I'm trying to service a customer who needs a certain product. We show him
Yeah,
that product, and we create a process based on whatever need we are trying to serve or whatever value we are trying to create in the market.
yeah,
So, So it's great that there is a technology creator and a licensee. But then who takes the guarantee that, this is the machine, this is the output it will give, this is the performance it will give? There has to be that. I presume that you guys probably have those tie-ups, but it'll be interesting from a customer standpoint. A lot of people who would hopefully listen to this podcast are potential customers. And how do they get that assurance that Pulpac won't just wash their hands off, that we provided the technology, we don't care if the machine performs, because talk to this guy if the machine doesn't perform. Because then, in a way, there's a challenge for the customer, and how do you address that?
Sure. And normally that guarantee for the equipment would come from the equipment manufacturer, right? I mean, they are the ones that are providing the guarantees for the functionality of the machine as well. Producer responsibility for the product itself is, of course, allocated to the converter. We are in most cases here as a supporting function, right? Which they can call us in and support with whatever problem they have or technical assistance they need. But we are also actually hearing this feedback as well from the market, and we are ready to step in more and actually be a partner that can warrant functionality as well in certain cases, I would say as well. I mean, we are here to provide the securities for the clients. We're here to provide what they need, basically. It is a novel technology still, and we realize that. So for us to make the clients, the converters, the customers feel secure. That's what it's all about. So they can actually take on this new technology and scale it. So it varies. I don't know if
Yeah.
that's a good
No, no, and,
answer,
and
but
I'm glad that
we
you're
are here.
thinking
We
of
are
it.
here.
Yeah, I'm
Sorry?
glad you're thinking of it like that,
Yeah.
because the challenge, or the other way, if I'm in your place, is that we have very secure tie-ups with the machinery manufacturers. Yes, we are the technology providers, but not like go and make your own machine, or it doesn't matter who makes the machine. It I think makes the customer more secure if it's like two or three manufacturers who are really good. They have a good name in the industry. They take the guarantee. So for example, we are buying a couple of new paper machines, for example,
Mhm.
even right now, but we only talk end to end, whether it's Voith, Valmet, Belmer, Alimo, whoever it is. Ultimately, the technologies can be varied, but in the end, I'll say that, the guarantee is end to end. We are not, you're not an equipment supplier. For us, you are a process supplier as well, and we'll discuss all the processes with you. But in the end, it's this kind of product, this is the output, and that is the guarantees that you take, based on which you have certain financial guarantees, as in bank guarantees. So what happens then is that I'm much more secure paying much higher prices than say an Asian supplier, compared to an Asian supplier, because I know that I have a partner who I can rely on. And I think that is an important part of business when it comes to the customer, because I have no clue about the technology. I'm not a machinery manufacturer. Ultimately, I'm a product manufacturer. So I think the other way to do it is that these are the great manufacturers. We'll work with them. We stand guarantee for their performance, and they also stand guarantee to make sure that the machine gives the output that is kind of guaranteed. So I don't know if you've looked at it from that lens, and how you are kind of making sure that that happens.
Yeah, and as I said, right, we can do that today as well. I mean, we can actually provide that type of certainty in various cases. But I mean, the questions always comes back as well. What is the clients and your unique selling point as well? What differentiates you as well when you are starting to make these items, and you would like to do some design features and alternate, and perhaps you're even best at converting an infrastructure and how to run the machines, right? That might be your advantage in the market space. So you can actually lower the price a little bit further or whatever. So our possibility to monitor production is always a challenge, right? I mean, we can't give out guarantees if we're not controlling it as well. So it's a two-way street. But in certain cases, yeah, sure. I mean, we are here to support, and and give to infuse the system with trust, right? So we are able to do that today if we have clients that are asking for it for certain
And
product categories, and the
yeah,
recipes and
wherever
everything.
you are comfortable. Yeah. And do you have you identified a couple of machinery manufacturers, fabricators who you can rely on now, and you can tell the customer that guys go to this guy, this guy is good.
Sure, absolutely. So today we have three of them that are turnkey providers. So we have one in Taiwan who's actually building the Scala. It is a injection molding company. They are building injection molding machines. So they are utilizing their clamping unit, adapting it with our process with the mill to web system and integrating it. We have developed the machine ourselves, so or in partnership with them, but they are building it for us. Then we have in Sweden a turnkey provider called TechDrive, who are building a version of the modular one, and now we also have one in the US, Kurti Joa, who is also providing machinery. And it was actually just last week we announced that now we have a demo line, right, a pilot line in Sheboygan in Wisconsin in the United States, which you can actually go and visit if you like to see it live. If you are in the US, if you are
No,
in Europe,
absolutely.
it's
Yeah.
easier to come to Sweden, I guess. Yeah,
Yeah. And it's great that you've chosen a Taiwanese for the smaller one because, of
yeah,
course, they are like I know that in the wet molding side they are so good in
yeah,
Taiwan, and they probably have injection molding which is so good. So and the cost of manufacturing compared to Sweden or US would be very different. And I think that in the end, I think your passion for scaling the idea will happen as the cost of machines go down as well. And I know that China is ingenious again, like we can say whatever we want about the Chinese, but they are super innovative and they can keep kind of coming out with new ideas. So I'm sure, there'll be discussions that will happen, and hopefully there'll be some manufacturers who you can trust, and they can come in as well and expand the possibilities as you're trying to do for the
exactly.
industry itself.
Exactly. I mean, companies in the US often demand American made equipment as well. So that is a challenge. So we need to scale into there as well. But
Yeah.
yeah, that's it. Yeah, we need to find more suppliers that are willing to make equipment and make tooling as well. So I mean, we have partners who are actually making dedicated dry motor tooling as well. So
Yeah. And just staying with tooling, so we know that again, comparing it with wet molding, there's a certain life that you get of the tool. And then you have to replace it, or you have to, redo it, or check the holes or whatever. And there's a lot of challenge that happens with a couple of things. Number one is clogging of holes that you have to sort. Number two is alignment because of the moving parts. That's a big challenge in a wet molding process. So little more on the tooling itself. Does it have a similar challenge in case of dry molding, or no? Those challenges don't exist.
of course there are challenges and also very product specific, I would say. I mean, we have wear and tear parts in the tooling. So I mean, as I said, we make everything in one step. We are forming, we are cutting and everything, and anvils and knives gets worn out at a certain time, right? So you need to replace them. In some cases, we utilize a silicone or a soft part of the tool as well. That also actually degrades over time, so you need to replace it. Uh, but other than that, I mean, we're utilizing hardened, tool steel mostly. So it's pretty long lasting, I would say.
That's wonderful. And that takes me to products. So it's been so interesting, again, Linus, for me to see the kind of products you can do. There is a huge challenge when it comes to undercuts, for example, in wet molding. And I see that you are able to do undercuts, snap fits, different densities, etc., which you already mentioned in terms of the weight. And that's really interesting. So, but I'm going to inverse the question. What are things that you cannot do and wet molding can do? For example, can you go as deep as possible for a beverage cup or a delivery container? Are there limitations there? So talk to me on both sides, things that you
Sure.
can do which wet molding cannot do, but also things that you cannot do and wet molding can do.
Sure, absolutely. Yeah, yeah, yeah. Yeah, dry molding is suitable for a variety of things, and some cases wet molding is better as well. We talked a little bit about it as well, right? I mean, deep draws. I mean, when we do something in dry molding, we partly utilize the ductility or the formability of the web itself, but that has a limit on how deep it can draw. What we then can do is actually drape the tool as well. So we actually feed in material into a cavity to form something deeper, like a food container or something like that. Drink cup, I think that is a hard category to challenge. I mean, those are very cheap as it is today. So it needs to make very good sense if we should make something like that. But uh, deep deep stuff with multi-compartment is typically harder, I would say, for dry molding than it is for wet molding. The other thing here is to consider is that, okay, if we have something very deep, we need to have more material available to us in order for us to drape the tooling and get it into place where we need it. And therefore, it will actually limit the amount of cavities we can put in a machine. So the size of the machine also comes in as a consideration when we're talking about unit cost, because it always comes down to unit cost when we talk about these items. It needs to be cheap. It needs to be competitive, I would say. So there are limits or there are balances here where I would say that wet molding, perhaps, yeah, they could be better for certain types of applications. For smaller parts or mid-sized parts, fairly deep, or I mean, it's drink lids or single-use cutlery. It's a perfect fit for dry molding. Small, high volume, high speed. Ductility isn't that or deep. They aren't really that deep. They're a couple of centimeters deep, right? Perfect. We can just punch out those products like a machine gun or something. I don't know. But deeper stuff like a salad bowl or a food container, yeah, we do that as well. But it has limitations, and those we are always trying to expand and evaluate how far can we go. Wet
And you
molding
also
and
mentioned you also mentioned multi-compartment, and I guess as you were
yeah,
speaking, I was thinking, yeah, that could be a challenge as well because you're trying to take the fiber and then kind of press it into shape, and as soon as there are compartments, there could be challenges. So, what is
yeah.
the kind of challenge that is caused in that process?
Yeah, so what happens is that you would like to drape the tool, right? And then the cavities start to compete with the material, which is others, and then you get tears and stretches in the material, and that is something that you don't want. You don't want to have holes in the product. You want to have an even material thickness and good distribution of fiber. So it comes down to actually controlling that, how the material flows in the mold.
Yeah, super
But
interesting.
shapes
So,
and that sort of stuff, yeah,
yeah,
sure.
till it's single compartment. I think it would work really well, and till it's not too deep. I think you mentioned at least going towards, say, maybe if we were to look at centimeters, maybe 5 centimeters would not be an issue, but beyond that, it could become a little bit of a challenge.
We have done deeper stuff as well, but
Okay.
it comes yeah, we have done deeper stuff, but still in prototype stage. I might add as well. So
Yeah.
it's always how do we balance that? What do we take the next step in industrializing, showcasing, high volume as well.
Yeah.
So finding that balance, pushing that limit, that is what we are focusing on.
That's super interesting. Also, you seem to be like a patent machine. What I read was over 350 patents in 56 countries. How does that work? And you expect to go to 1,500 patents. So
Yeah.
that's crazy. And is that all, when we are looking at that, is that all in the dry molding process, or that's also to do with all the consulting that you did? Is that beyond dry
No, no,
molding, or the 350 is only dry molding?
yeah, that is Pulpac business. That is Pulpac business and
That's
dominated.
amazing.
And I guess we actually already have sort of visibility of 1500 as well. I mean, many of the patents aren't public yet, and I mean they have been applied for. So the grants, I mean, we have 330 grants at this stage, right? Approved patents. So what is ungranted yet, and we're waiting for the authorities to approve or not, right? I mean, that could be easily somewhere around that figure, 1500 something, 1000 or 1500 something like that. But yeah, it's important, right? I mean. Uh, to stay in control of this, and I mean to be able to do the licensing business, patents and IP is a hygienic factor. You need to have the rights to utilize the technology, right? That's how it works. But our door is open to anyone who would like to join and become a member of the DMF family, right? To start converting or participate in developing a part of the technology tool or machinery, whatever it could be. But yeah, IP, yeah, we are producing a lot of IP. We have an
I'm
in-house
sure. Yeah, I'm
IP
sure you
department.
have a full team that
Yeah,
is continuously kept busy with so many IPs. We can barely get through 3 to 5 in a year. I mean, it takes too much effort, takes too much time. Yeah, you have to have a machine that works properly to get those IPs.
it's
But that's your business as well. You have to have the patents to be able to ensure that the technology is kept protected.
and it's expensive as well.
Oh yeah, that's true. I didn't think of that. Of course, each application, and you said 56 countries, so so there are multiple applications to different countries as well, not just in Sweden.
Yeah, exactly. 54 patent families, and then you apply in different countries and get different grants and so on. Yeah.
Amazing. That's crazy. And the other one which I read, which is super fascinating again, that there is an aim to replace 1 million tons of plastic.
Mm.
So talk to me a little more about that. That's a big number to kind of aim for, and what is the kind of timeline that you're looking at?
Yeah. So it was actually the first goal when we started Pulpac to replace 1%, 1 million tons of the global consumption of single-use plastics. And back then in 2018, it was roughly 1% of world consumption. But it has actually increased. The consumption has increased. So I think it's more or less 0.5% or something like that today. But it was based out of
You have to grow your
more,
target now to 2
yeah,
million.
yeah. But that's the first stage for us. We aren't there yet to replace 1 million tons of plastics, and that is something that we can't do ourselves. That would be a huge converting engine, right? If we should do that ourselves, so we need partners. We need converters that can help us. I read. I think it is like we are consuming 450 million tons of plastics each year, and 40% of that is going to single use and packaging.
70%.
70%. Oh,
Yep,
really?
70% of the packaging plastic. I'm not
Yeah.
talking about other
Yeah.
plastic. So if you look at just the packaging plastic, it is 70% of that single use, which is crazy, right? 12 to 15 minutes of usage is all there is for the convenience. That's the kind of craziness. And you're of course right out there to replace those, which is really amazing. So the other statement which is fascinating for me and I want to understand more is we built Pulpac on Swedish common sense, power of shared purpose and strength of collective. So of
Yeah.
course we all look up to Sweden, but tell us more about this thought process.
Yeah, sure. Yeah, I mean, the collective mindset, right? That is how we build companies, and I think that's a very modern way to build companies as well, in partnerships. I mean, collaborative spirit and doing things together. I mean, the old ways was to protect it, right? Close the doors, have drapes in front of your windows, and do something in the shadows. We would like to do something differently. We would like to collaborate with the industry, and whoever, I would say, who would like to get involved. You could see it from one perspective, right? And that's a very nice way, which I like to do, is that we don't actually have any competition. I mean, our doors is open. We would prefer a partnership with whoever, and they are welcome. And I don't know if that's a Swedish thing per se. I think that's more a general modern way of doing things, right? I mean, the challenge is so big, so I think we need to partner up. We need
No,
to do changes quickly.
I've right through my university years, again mid 90s. I've had numerous. I've been blessed by numerous very close Swedish friends, and I've worked closely with Inventia, Rise,
Yeah.
KTH, and a lot of these institutes. I've had friends in Lund who have again, but I've always found that spirit of innovation. There is a different spirit of innovation. I don't know if it's something to do with the general Scandinavian spirit or the education system, but there is that tendency, and I could go very wide when it comes to innovation. I've looked at musicians from Sweden, but they make music differently. So I don't know if it's something. So I'm obviously intrigued when you say Swedish common sense. I don't know what it is, but there is something in the air there which enables innovation. And I've had so many and amazing companies, even start like things like Skype and the early stage of numerous companies. And of course, we can keep naming companies from Sweden which have really made a big difference in this world. Um, there is something in the air. So I was thinking, when you say Swedish common sense, that you're going to educate us a little more on that.
What a nice thing to say as well. Yeah. um, I don't know. I mean, I think that perhaps I guess we have it right. We have the incentive from the government, from school, from everything to perhaps be creative. I think. I don't know. I don't know if that's a Swedish thing per se, but it's nice to be free in mind, I guess, and to have the space to be able to follow your thinking as well and actually act on it as well. That's a nice thing. That's a very nice thing. Yeah, Swedish thinking. Yeah,
No, and I see that in so many
common
ways.
sense.
I was thinking as you were speaking, I was thinking of a friend of mine in
Yeah.
he was living in Gothenburg and working in Brno. Uh, he was just building houses, but he wanted to restore the older way of doing things. How the Swedes made the houses before. His name was Ulf, and it was such a beautiful thing to see how passionate he was about doing this. It didn't matter whether anybody wanted it or didn't. There would be that odd person who wanted his thing, but this was what he wanted to do: build houses the way traditionally they were done. And have again, at some
Of
point
course.
we'll have a drink and lots of conversation on that. And I have just so many friends who've inspired me for their thinking with their thinking, and lots of them. And as you're saying, it probably comes from something in the culture of thinking as you want, and really exploring life and not just being limited by. You talked about your father earlier, and what you started with was that innovation comes from thinking in different directions. And you're so
Yeah.
right, because if you just get unilateral and then I'm only going to be a cellulose scientist, there's only that much you're going to try and do. So for example, even our R&D facility, we are trying to place it in a place where there is a lot of different disciplines, not just a single cellulosic discipline, for example, because that's what will get ideas going, and different people and different ideas will come from there. So I really appreciate something in the air in Sweden which is kind of enabling this to happen in general.
Different views or perspective as well. Perhaps traveling as well is a good thing, right?
True.
Seeing different things. Yeah.
Yeah, yeah. Okay, a switch, and I'm taking it towards closure as well. I respect your time and thank you for giving us so much of it.
Oh, thank
But
you.
what about regulation and policy? And I'm sure
Yeah.
that creates a big difference as well. And how involved are you getting in something like that, and how is it impacting your business?
Yeah, of course, that is affecting our business, right? And it's an important topic. And EU legislation now is driving hard on pollution, as in general, right? Um, I think it's an important tool in the toolbox for humanity to actually make a change fast, as long as it's stimulating innovation in a good way. That's an important part for me, at least, right? I mean, it's very easy to see what we have at hand and start regulating things. And now we have a very big legislative action coming into play here in Europe, which is the Plastic and Packaging Waste Directive. And now it will be translated into local law in different countries, and that will take, I don't know, a couple of years for some countries and a little bit shorter in others. But for those countries to have that in mind, I think that is very important. We are, I mean, we are speaking our mind on this. I think that is important part, right? I think that's a very important. But I also see that there is a lot of pushback, right? And that is quite dangerous. Of course, it should make sense. Let's go back to the Swedish common sense again, right? It needs to it needs to be stimulating that we are actually utilizing this tool in a good way. There's another one coming online quite soon as well in returns to greenwashing and consumer right. They have the right to actually understand what's in the packaging and what's in the products they use. I think that's a very good thing in general. Greenwashing is very bad. It's very bad.
And also, I see a switch. Sorry if I interrupted you,
Yeah,
but
sure, sure, sure.
I see a switch also. Europe has always been like a front runner when it comes to sustainability, but I
Yeah,
also see a switch towards recycling a lot, and
yeah,
that's a challenge that I find because ultimately there is no such thing as recycling. It's only downcycling, and it has to get out at some point. And it's better if it gets out as fiber than a petroleum polymer. So are you seeing that as a challenge at all, or you think it's just a journey and it's just one step at a time?
I think that's a good thing. So what we are now pushing for, or what they are pushing for quite much, is anti-pollution or anti-littering, right? And that is the hard part. I mean, in the best of worlds, we could actually recycle all plastics. That is not going to happen, unfortunately. But in the best of worlds, that would be the case. I think recycling is a good way to take care of the materials that we use. And it should be able to be recycled. And to create infrastructure around that is a hard task. And this is the main reason I believe in fiber. I mean, the volumes are so vast. It's so big amounts of packaging that we use every day. We need to take care of it in some way. Yes, it's downcycling, of course. I mean, we are reusing the materials until we can't use them anymore. But once we have used them enough, I mean, they shouldn't pollute. It should be renewable. That's
Yep.
a very important part. I mean, hopefully we will see some other parts of the world, following quite soon. I mean, for instance, US, we know for sure is behind on legislative action on pollution and anti-littering. They are starting to wake up, which I think is very good. Other parts of the world as well. But we need to be able to provide an alternative that makes sense for them to replace. And that is what we are trying to do here at Pulpac and trying to contribute in our way.
An alternative, like you mentioned before, it has to be at scale because
Yeah.
otherwise, like there is, I know that we are working with numerous big players globally, and even a small shampoo sachet with Unilever, for example, is 16,000 tons in India alone.
Yeah.
So that's what we are talking about. So of course, from a perspective of a customer and appreciation of their challenges, they have to have an alternate material at that level because you can't just have a good 1,000 ton because that won't help, right? It has to
No.
be in multiples of thousands. So I'm glad that you're thinking of it like that. Just a quick detour and then we'll close. I also see that you're building a very strong team and culture. And
Yeah.
that probably is very different from your consulting days because the kind of people that are probably joining are different and they have different talents. How do you look at that? How do you look at building Pulp Pack as a bigger team and having a culture of innovation and creativity because that has to come in, right? So how are you looking at that and how are you building towards a strong team?
I think actually that goes back to where we started this discussion today as well. I mean, that was a driving force from the beginning, uh, to create the competences and capacity to be able to create more stuff, right? To have that internally at Pulpac or at any company, right? To be able to do more, to be creative, right? I think that is for sure a driving force within Pulpac itself. That's a cultural thing that we have tried or have created and tried to actually continue to enhance, so to say. Yeah, we are quite many. We are like 110 people working at Pulpac these days. So we have grown quite fast for the last 6 years, and especially the last two. But it's a fantastic team, and I mean everyone is very committed to do something good, and I think that is an important part. It makes it easier to find talent as well if you have a strong why. And replacing plastics and helping the climate is a good one. I can tell you that.
For sure, but I'm sure there is more that goes into it as you become bigger and number of people
Yeah.
grows and complexities grow. Um, Another question is how easy or tough have you found raising money and raising funds at the right time? Has that been relatively a smooth sail, or has that been a challenge? And I presume you would have had to dilute part of the holding as you go ahead. And has that been difficult? How do you look at fundraising?
Sure. Yeah, yes, we have been diluted and we have raised capital. We have raised roughly 40 million euros so far during these 6 years. Uh, and we did a quite large investment round now in roughly 18 months ago, something like that, in the end of 2022. We raised 34 million euros to actually expand the operations in general. It's always tough to raise money, right? It's a lot of hard work to do that, and I think perhaps we had good timing as well. We were just in the end of the last sort of up time, so to say, in the macroeconomic community, and then if we were to raise money last year, I would say that would be tougher than it was in 2022 for sure. So we timed the window quite nicely. We chose to raise money in order for us to expand, which was, I think, a good choice, but also to, I would say, attract or gain competences within the company as well. So what we did in 2022 was to attract partners, shareholders that actually could contribute to the business as well. So we formed what we call the Cross-Industrial Alliance, where we took in some strategics, we took in some brand companies that has had a lot of brand knowledge as well. We took in some, you know, climate smart or sustainable venture funds and so on. We had Stora Enso, which is a paper mill. We had Amcor, who is from the converting industry as well. So in order for us to expand and industrialize even faster, it was important for us to bring in the right type of capital as well. And from my point of view, it was very successful. Now we have the competences we need, and also, of course, the capital to continue to scale and to enter into new markets and support clients in a good way. But it takes time. It's a lot of effort to to raise money for sure.
And just taking the scale forward. So if you were to look at, say, 5 years from now, what would be an ideal situation for Pulpac? What is the kind of scale you would look at, and what is the kind of impact you would look at?
Yeah, at least replaced 1 million tons of plastics. At least.
It's already gone to 2 million, Linus, no
Yeah,
longer 1 million. And
yeah,
if
for
it
sure.
grows the way it is growing, you may have to go to 3 million.
Yeah, yes,
So that's
absolutely,
beautiful. And good to hear
absolutely.
that, and good to hear that spirit. And that takes me to my final question. What is good garbage to you?
What's good garbage? Yeah. So for sure, something renewable, something that doesn't pollute, for sure. It shouldn't stay on the ground. It should degrade naturally if we don't take care of it. But it should also be recyclable, of course, utilized many times, like fiber.
Super, Linus. This has been such a joy to talk to you and learn from you. Thank you for doing things which are not normal. Thank you for challenging status quo and taking the industry to a different direction. I wish you nothing but lots and lots of success, because that success means a cleaner planet and a beautiful world for us. So thank you for what you do, and thank you for being on the show.
Absolutely. Likewise. Appreciate the opportunity as well. It was very nice to talk to you.